Let x represent the full length of a certain species of newt. Assume that x has a normal probability distribution with mean 191 inches and standard deviation 4.5 inches. You intend to measure a random sample of n equals 24 newts. The bell curve below represents the distribution of these sample means. The scale on the horizontal axis is the standard error of the sampling distribution. Complete the indicated boxes correct to 2 decimal places. Well, the boxes didn't show here, but effectively what we want to do is identify values along the x-axis, so I'll just choose a few of them to enter so that we can get started. Now, what we need to do is we need to find the mean and the standard deviation of this normal distribution. So that was provided as having a mean of 191 inches with a standard deviation of 4.5 inches. Now, this isn't the mean and standard deviation of the sampling distribution. The mean and standard deviation of the sampling distribution changes depending on what size sample you have. So the mean of a sampling distribution for the mean, it is just equal to the mean of your population, so it's still 191 inches. The standard deviation of your sampling distribution for the mean is the original population standard deviation divided by the square root of the sample size. So when we put that into the calculator, we get an approximation of 4.5 divided by the square root of 24 comes up to 0.92. And I'm just going to use 2 decimals, but follow any rounding rules that are given in your problem. Now, to label the axis. The axis is still measured in inches. The mean is still located right in the center, whether we have a sampling distribution for the mean or if we just have the population, which is normal. Because both distributions are normal distributions. So the mean is, in this case, the mean of the sampling distribution, which is 191. Now, if we start going out from the mean, 1 standard deviation to the right or 1 standard deviation to the left, we just simply add our new standard deviation or subtract our new standard deviation. So using the calculator, if I take 191 minus 0.92 and 191 plus 0.92, then 190.08, and I'm going to get rid of my box so I have a little bit more room to write, 190.08, that one's that way, and 191.92 this way. If we continue another standard deviation, we just simply add 0.92 to that value to go another standard deviation, so 192.84. And we could continue this process any number of standard deviations. The same for going to the left. If I then take 190.08 minus another standard deviation, that puts me at 189.16.